approximate areas with Riemann sums. So Riemann sums, we just need to know some geometry, and it follows more or less intuitively. So we want to approximate, let's say, the area under this curve from A to B. And this is just any function f of x. Now, the way we could do this is we could get rectangles. We could approximate the area of each one of these rectangles to being roughly the area underneath this curve from A to B. So one way we could do this is we could say, well, let's divide A to B in how many equal lengths? 1, 2, 3, 4. So this is 4 rectangles that I'm going to be using. And N is typically used as number of rectangles. And then I have A and B here, and if I wanted to find out the width, let's make this a special color. I don't know. Let's make it pink. Let's see. We always use pink. Say yellow. I don't know. So let's say here this is delta x. This length here. This is the width of each rectangle, and you should sort of just be able to see that if I want to get what delta x is, well, it's just the length from A to B, which is B minus A, so delta x, what is it going to be? Well, it's not B minus A, it's this entire length divided up into n equal parts. So it's B minus A over n is the width of any one rectangle. We denote that as delta x, width of rectangle. Now, what this does is it divides it up into a certain number of pieces. You know, we have each one is delta x. So if I wanted to find the area, I would need just delta x times whatever the height of this rectangle is. Now, the height of this rectangle, I could take a left endpoint, which means that I'm starting at A. If I started with right endpoints, so this is a left endpoint, and we're going to do left endpoints now. So left endpoint, I could take for the height of this rectangle. So then that means that the entire rectangle would look like this. And that's one rectangle. So the height of this would be f of A, right? Just f of A, where my function is at A. And then the area would be f of A times delta x. Plus, and I want to continue to use left endpoints. So the right endpoint for this rectangle would be this point right here. But it's the left endpoint for the next rectangle that I take, which is this one right here. And now this value right here is just A plus delta x. And I should see that it's A plus delta x. I'll call it, for the time being, let's call it x1. Let's call A x0, my starting point. x1. So it's going to be f of, so this is x1, A plus delta x. F of x1 is the height of that rectangle times, again, the width of the rectangle is delta x. And I'm using left endpoints here. So the left endpoint, I go to the next one. And then this here. Right? This point right here, I'll call it x2. But we should see that it's just A plus 2 delta x's. So this is A plus 2 delta x's, right? Because I went from A and then I moved delta x over. That's the next point. Then I moved delta x again. This length is delta x, right? And now I'm at x2. So the area of this rectangle right here, right, is going to be f of x2 times delta x. And then again, I do left endpoints, and it looks like this rectangle. It's above. It's going to be an overestimation of the area under that curve for the region. But these were underestimations, these three, and this is my last rectangle. I'm at B at the end of this rectangle, right? So plus, and this point right here is x3, let's say. And again, it's going to be A plus 3 delta x's. And that's f of x3 times the width of this rectangle is, again, delta x. And then this would be the area under the curve using left endpoints. Let's contrast this very quickly with what it looks like if I were to use right endpoints to get this in the general case. So in this case, what you do is you start off at x1. You start off with this point right here, which is x1. Okay, and that's a right endpoint for this first rectangle. It would look like this rectangle. It would look like this piece. And that's a right endpoint. So now we would be doing it using right endpoints if I did this way. And it's going to be a very similar thing. Again, delta x is just going to be this length, which we already should see as being, if it's equally divided, if each one of these pieces are equally divided, then delta x is just the length from b to a, which is b minus a, just like in the other example, divided by how many rectangles I have. In this case, n is 4, but let's just imagine in the general that it's n rectangles. So in this case, it would be b minus a over 4 would be the delta x, would be the width of any one rectangle. And again, in this case, I'm taking right endpoints. So what does that look like? So x1 in this case, right? x1 in this case is going to be equal to a plus delta x. And you start off with that value. And that's going to be, what's the height of this rectangle in this case? It's f of x1 times, that's the height of the rectangle, that's this length, right? Times delta x is the area of this first rectangle. And then I take a right endpoint for my next rectangle, which is this over here, and I call this point x2, and we should see x2 as being a plus 2 delta x's plus, and I add the value of this rectangle, and where they end is just slightly different. So if we contrast to left endpoints, where this one's going to end, it's going to end with a height of the b value, but there's still going to be 4 rectangles, and you should just sort of just go back and forth between these two real quick and see what the actual difference is between right and left endpoints. So if I have the right endpoint right here, right, for x3, this is x sub 3, right, and again, x sub 3 is going to be equal to, I'm going to put it right underneath, a plus 3 delta x's, right? This length is delta x. How far away is it? It's 1 delta x, 2 delta x's, 3 delta x's. So I got to add 3 delta x's to get to x3. And then that's the height of this rectangle, so it's f of x sub 3 times delta x plus, and then the last right endpoint is right here. And you can see that that rectangle is an underestimation of the area of the curve, and that's just the value of b. You could call it x4. And x4 is equal to a plus 4 delta x's. X sub 4 delta x. And this would be the approximation of the area underneath the curve, right? Approximate, this is the approximate symbol, right? Don't forget it's an approximation for the area underneath this curve from A to B, and that's with right endpoints. Here, if you go back, if we look at what it looks like for left endpoints, right, where did we end? We ended with the height being x3. If we call this x0, x1, and then b x4, everything stays the same. It's only that I'm starting with a left endpoint here, and I'm taking left endpoints for each rectangle. And in this case, I'm taking right endpoints. Taking right endpoints for this one, right? I'm taking right endpoints here in this case. Okay, now there's one last case that we should go through. It's if we take midpoints. So the midpoint looks something like this. If I take midpoints, then I would have it where I want to find out this value right here, and I take that to be my first value. So what would that look like? So that's going to be the middle between these two, right? So it's going to be that the rectangle looks like this. So I would do f of the middle between the right endpoint and the left endpoint. And I could call that value x0, x1, and I would go here. This would be the next midpoint. I would have to find out what that midpoint is. I just have to find the middle between what the left endpoint would be and what the right endpoint would be. And if you even went like this, if you said this is x0 and then this is x1, just find the middle between x0 and x1 and then do f of that value. So let's call it x, I don't know, x bar 0, right? The middle between the two, x bar 0. So it would be the height of the rectangle would be x bar sub 0 times delta x again, and that would be the area of this first rectangle. You would just have to find the middle. It depends upon what x1 and x0 are, but you could find the middle between those two fairly easily. You could add them and then divide by 2, and then that would be the middle, okay, for x bar, and that's midpoints, okay, and it would look like this, okay, it would look like this. So the midpoint between these. So I drew the 4 rectangles with midpoints in this example as best I could. And you would, again, get an approximation. You would find the middle between x1 and x2, between x2 and x3, and then those would be the values you take for the heights of your rectangle.